only be 3 numbers. I'm recording now, just so you know. Let's go through it quickly. Now, Alistair mentioned he had a different method, which I don't think is maybe a different method, but I think he might have generalized the formula a little bit. So I'm just going to go through it quickly. So the surface area of a cylinder is, I'm sure you're now aware, because you seem to be doing it right, the 2 circles and the rectangle. Okay, the circles have a diameter of what in this case? Anyone? 10. Good. The diameter is 10. All right. What is the width of the rectangle? 15. Okay. How do we work out the length of the rectangle? How do we work it out? Come on, guys. There was lots of answers. You should all be jumping at this then if you know how to do it. Otherwise, I'm going to think maybe you just wrote down someone else's answer. Come on. How do you know this length? What's it the same as? Yeah, but the other side of the rectangle, but it's the same as something else as well. The circumference of the circle. Okay, we've done that. Okay, if you got the right answer, you must have done this. So this circumference here should match that length. What's the formula for the circumference then? Two pi r. Okay, let's use 2 pi r. That's what I want to use. Or some of you might have used pi d. Okay, so just to summarize, is there a formula for this? We've got to do the area of the circles, 2 of them. What's the formula for the area of a circle? So the area, come on, computer, what's going wrong? Area of the circle, what's the formula? Yeah, pi r squared. So the formula for the surface area of a cylinder, okay, is we have 2 lots of a circle, okay, plus a rectangle which has this we would call the height of the cylinder, and this would be the circumference of the circle. So we could call it 2 pi r. Okay, so the area of a circle is pi r squared. So if I were to write that out, I could have 2 pi r squared plus 2 pi r h. Or just to change this end one, 2 pi r squared plus pi d h, because the 2r is the same as the d. Alistair, does that look a little bit like you were working on? Okay, so that's why it's not a different method, it's just writing the formula for it. So what we've been doing. So basically then, guys, you should have worked out the formula for the area of the 2 circles. So the 2 lots of pi r squared. So that's 2 times pi times, what's r? And what is it? Which is what? What number? Gets 5. Okay. So we've got 2 pi times 5 squared, and over here we've got pi times d is 10. and the h is the 15. Okay, so we've put all those numbers in and we work it out. Okay, and I do believe if you work that out on your calculator, you get the answer 628.3 something. Yeah, so I've written that to 4 figures, but we only want the 1, 2, 3, and then the 3, does it round it up or not? No. So our answer should be 628, which is what a lot of people were putting on. What are the units? So that's surface area. So what do I put here? What are the units of that? What is it?
Square centimeter.
Yeah, good. Square centimeters. Well done. Okay. So any questions on that? Was it all okay? So we have taken a little step forward by saying we have a formula now. So we could write that down instead of working out in parts, but that seemed to be going all right for you. So the surface area of a cylinder, we could write as 2 pi r squared, because that's the 2 times the circles, plus 2 pi r h, because that's the rectangle. Okay, so we have a formula now that we could just plug into if we like, but it's better to understand it if we've got it. All right, so unless there's any particular questions on that, we'll move on. Do I have any questions, or are we all good? All good? Okay, right, the next thing I want to be able to do, guys, we're not jumping straight into volume of cylinder. I would like to know whether you, because we should have done this last year, but I think this is the point we got mixed up with lockdown last year. So I'm just checking that we can work out the volume of a prism in this case, right? So a few different types of prisms. So this has several names. It can be a rectangular prism. What other name might it have? Anyone know? No? No guessing even? Nothing? Not even a no, I don't know? Nothing? You're just going to leave me sat talking to a computer?
I'm not sure.
No? Okay. Go for it.
Rectangle.
It's based on a rectangle. Thanks for at least trying. Nice to hear a voice. So we have a rectangular prism. You might, as soon as I write it, you're going to go, oh yeah. It be called a cuboid. It's not a cube because it's not all squares, but a cuboid because it's, at least you could have given a guess that it's a box, because we always use boxes that shape, but no one even wanted to try that. Okay, but the definition of a prism, which I know we talked about last year, okay, is it's a 3-dimensional object with a constant cross-sectional area. Okay, so 3-dimensional object with a constant cross-sectional area. So what do I mean by a cross-sectional area? Does anyone know? Anyone want to have a go at guessing, or are you all just going to say no, don't have any idea? Some form of feedback, please. No.
Does it have anything to do with the amount of sides it has?
No, it doesn't, but good guess. So I'm just going to take you back up to a cylinder, and say, although technically it's not a prism, we do talk about it in the same brackets. So a cylinder has a constant cross section, so it's like a prism, and the cross section that's constant is the circle. Okay, so the constant cross section of a cylinder is a circle, and that's because if I were to chop a cylinder along this way, what shape would I get everywhere? I'd keep the circle, wouldn't I? If you were to chop, I don't suppose, do you know sticks of rock, that candy that comes in cylinder shapes and has letters running through it? You know about that? Well, if you chop that, you always get the writing because it goes all the way through. It's amazing how they make it. But this is a cylinder because it's got a circle all the way through. It doesn't matter where I cut it. If I cut it in this direction, okay, so slice it, okay, I always get a circle. So this cuboid is also a cylinder because what shape will I get if I sorry, not a cylinder. This cuboid is also a prism because if I cut it anywhere, what shape do I get?
Or square.
What shape? What shape do I get it if I cut it? A rectangle, yeah. So because it's got a rectangle, the thing with a cuboid, it's a special one because it can go in any direction. But here what we do is we pick one of the ends, okay? And I know that if I chop it in half, what shape would I see? Well, I'd see another rectangle, right? What shape is on the other end? Well, it's exactly the same rectangle. It's the same one all the time. It doesn't matter where I cut it, yeah? Does that make sense? So the same thing here, look. It's a different size cuboid. I'm going to do it a different way this time. I'm going to take the top one, okay? If I chop this, right, I'll put dotted lines just to show that the bottom is the same as the top. If I chop it halfway through, I will have the same rectangle. Can you all see that? So they're all prisms in that way. I'm not going to go on to calculating them yet. I'm going to skip these ones. But look, this is another type of prism. Okay, what's the shape is the constant cross section on this one? The triangle, good. Yeah. So there's the triangle on one end. Here's the triangle on the other. And if I were to chop it down the middle, look, the triangle would still be there. All right. What about this one? What's the constant cross section? Good, yeah. So here is the end, okay? It's the trapezium or the trapezoid, okay? If I were to, it's a bit harder to draw, but if I were to look at the other end of it, I'd still have the same trapezoid, okay? And if I were to chop it in the middle, I would get the same one again. So that's a trapezoid, okay? They're all prisms because they have a constant cross section. Now, I go back up to the cuboids, all right? When we want to work out the volume, okay, the volume of a prism, okay, we do this by working out the area of the cross section, okay, multiplied by, well, we could call it its depth or its height or whatever. So I'm going to call it its depth, but it does depend on what direction you lay it down or stand it up, whatever, whether you think it's a depth or not. Okay. Does that make sense to you? If I say the volume of the prism is the area of the cross section multiplied by its depth. Any questions on that? What I mean by that? Okay, what does volume mean?
The cuboid.
Yeah, a little bit more detail. I think you know. Just could you express that a little bit clearer? What do you mean by the entire?
Space that the 3D shape takes on.
Yeah, exactly that. I think if you watch that, I think it was a video. If you were to put it in a bath, do you remember the story of that? The scientist that sat in the bath and said "Eureka" because he wanted to know how to work out the volume of complicated shapes, and he worked out if you stick something in a bath of water and the water was at the very top, water will then come out, and the amount of water that comes out is the amount of space that the shape must have taken up. And that's how you can work out the volume of any shape, because you can put water in a nice easy shape to work out the volume of, like a cuboid. So a cuboid is actually quite easy to do. So what we're going to do is the volume of, in this case, let's work out A. So the volume of the cuboid, okay. Well, the cross section is what shape? For this question here, what's the shape of the cross section again? It's not square, but it is a rectangle. I get the idea. You've got to be careful with saying squares because it's not quite a square. It might look like it, but look at the numbers. They're all different. So, but we do have a rectangle. Okay. I might color that one in green just for now so you can see. Okay. So that's this. That's the cross section. Give it an X. That's not going to show up. That's the cross section. Okay. And then we multiply it by the depth. So the depth is, well, if this is the cross section, the depth is going to be as you go along the shape, okay, along the direction that you would be cutting it, okay. So in this case, the depth is the 6 foot, okay. Right, so the 6 foot is the depth. Almost. I'm going to have to stop again in a minute. All right, so first of all, if that's the depth, what's the dimensions of the rectangle that we've decided is the cross section? Well, that's the area. I kind of said the dimensions. So it's 4 foot by 5 foot. So we've got these two numbers. But yeah, you're right, Jay. It's 20, isn't it? So we do 4 multiplied by 5 and we get 20. 20 what? Not quite. Yeah, square feet. All right, because it's an area. And then we have to multiply that by the depth, which is 6 feet. So our volume is 20 multiplied by 6, which is, can you do that for me? Luke probably do this in his head. Yeah. 120. What are the units? Yeah, cubic feet. Well done. Okay. So the volume of this cuboid is 120 cubic feet. Okay. Any questions on that? No? Okay. What I'm going to do then, guys, my time is almost out of Zoom, so I'm going to have to restart it. Okay. Can I get you to make sure that you've got this written down? Okay. So the dimensions are, this is 7.5. This is 2.5. Okay. This is the 2.5. And this one is the 11. Okay. So you've got those dimensions. What I'm going to get you to do, guys, I'm going to switch off Zoom. and restart it. So I would like you to come straight back on straight away, but then you're going to be working out the volume of this cuboid, please. Okay, just so you can say you can do it. Is that clear? Straight back on. Give me a chance to switch it off, but then straight back on.